This content is brought to you by Mazunder Academy.
Hello everyone. The next data structure, that is matrix. So matrix is a two-dimensional rectangular data structure. It can be created using the vector input. This is the syntax. Matrix is the function which will be used to create a matrix, then data, n row, n column, by row, dim names. So the first three argument must. Without this, matrix cannot be formed. And other two arguments are optional. If you want, you can pass. Otherwise, you can omit it. So let me tell you something. Data represents the input data or input vector, which will be the data elements of the matrix. N row is the number of row to be created. N col is the number of columns to be created. By row is logical. By default, by row is false. That means the data will be entered column by column. First, it will be first column complete, then second column complete, then third column complete, like that. If this by row is false, and if the by row is true, then the first row will be complete, then second row will be complete, then third row will be completed, like that. And dim names is used for if you want to give the names to your matrix, then you will use a list of length 2 by giving the row names and column names. I will show you in my demonstration. Let's see here. I have created a matrix with the function matrix, and the name of the matrix is M. And the data here 1 to 10, 1, 2, 3, 4, 5, 6 up to 10, and 2 rows and 5 columns. And if I run it, I will see the matrix here. Then, if I want to know how many rows and columns are available in a matrix, so n row of the matrix M. So n row, if I run it, I will get 2 here. That means there are 2 rows. If you want to know the number of columns, then n col, there are 5 columns. If I want to know both, like number of rows and number of columns, then that can be done using dim function. Dim of M will give me 2, 5, 2 rows and 5 columns. Next, let us see two very important functions, that is rbind and cbind. Let us create a matrix. Say M1 is a matrix created 1 to 10, 2, 5. So this is the shape of the matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now if I want to add a row to this matrix, that means you must supply 5 elements because you have 5 columns. So how can you do that? rbind on M1, and this is the data. This data will be used to create the new row. So if you run this, you can see a new row is created with the data what you have supplied. Then if you want to add a column here, then similar cbind is used for adding a column. So cbind M1 is the matrix where you are going to add, and these are the data which will create the column. So, and finally you are again storing it M1. So if you run this M1 and print, then you can see this -1, -2, -3 is added at the end as a new column. So this is the way rbind and cbind are used to add row and columns in a matrix. Next, say to create a matrix by row. So in that case, name of the matrix equal to matrix function, and then the data element, say for example I want to give data 11 to 20, number of rows say for example 2, and number of columns say 5, and by row equal to true. As I said, if I mention by row equal to true, then row by row it will fill. If I do not mention anything, then it will fill column by column, first column, then second column, then third column, like this. Now I mentioned by row equal to true, that means it will fill the first row, then second row, then third row, like this it will move. So if I print M, so you can see, so the data is 11, 12 up to 20. So you see 11, 12, 13, 14, 15, then 16, 17, 18, 19, 20. And if I do not mention this, then what will happen? You see 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it filled column by column. That is all about your by row concept. Next, the last argument of the matrix function, that is dimension names. So if you want to give some dimension name, you can pass as a list, or there are two other options. You can use column names, row names separately, or if you want to use dimension name, then dim name equal to list. Within list, you will first pass the row vector with all the names of the rows, and then column vector with all the names of the columns. But here I am using another function called call names. So call names of M1, I want to put column 1, column 2, column 3, column 4, column 5, column 6 instead of 1, 2, 3 by default. Similarly, row names, row 1, row 2, row 3, or you can give your any other names. It is just an example. So if I run it, if I run this also, and finally if I print it, then you can see that matrix M1, now the names has been changed as per our given names: col 1, col 2, col 3, row 1, row 2, row 3. So this is the way you can give your own names. This is one of the question, actually exam question. So you can see this was the question, what is the output of that. And after that we will see some of the operations on matrix. So mat1 and mat2, these are the two matrices created just for not simple matrix, mat1 and mat2. And then if we print them, then we can see mat1 is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And similarly mat2 also with the same data. Now if I want to add these two matrix, then just mat1 plus mat2. So it will give me the individual corresponding elements will be added. Similarly, if I want to subtract, then mat1 minus mat2, and it will subtract individual elements, and of course same element minus same element will be 0. If you want to multiply, then just put a star. So it will be individual multiplication, I mean element wise multiplication. But if I want to do matrix multiplication, then you have to put percent star percent, and both the matrix must be conformable for matrix multiplication. For example, here it is not possible. If you run, you will get an error like matrix multiplication is not conformable arguments because of the order, that number of column of the first matrix is equal to the number of row of second matrix. That condition not satisfied here. Next, if we want to find out the transpose of a matrix, then T is the function over the matrix which we have created. Then in that case it will do the transpose. I hope you remember what is transpose. Transpose means the interchange of rows and columns. So you can see it is now transposed. Met 1 was 1, 2, 3, 4, 5, 6, 7, 8, 9 like this. Then 10, 11, 12. Now it becomes rows becomes columns. Next, inverse of a matrix. Say we have created a small matrix here, met 3. It is like this 1, 2, 3, 4. Just to understand the inverse. And if you want to find the inverse of a matrix, then solve is the function which will evaluate the inverse of matrix. If you run, you will get the inverse of this, and you can check by using calculator. Then the last idea, determinant of a matrix. If you want to find out the determinant of a matrix, then det is the function det of mat3, and if you run, you will get the determinant of this matrix 1, 2, 3, 4, and you can check it. 1 multiply 4, 4, 4 minus 3 multiply 2, 6. So 4 minus 6 is minus 2. So your answer is minus 2. So these are the different operations available in matrix.
Please like, share, and subscribe our YouTube channel. Hit the bell icon to get the latest update.